This is part one of the series Transformations, and in this series we're going to investigate the four major types of geometric transformations: translation, reflection, rotation, and dilation. We're going to look at the ideas behind them, and we're going to look at how to perform them. So let's get started, and the first thing we need to know is, what is a transformation? A transformation is a function that moves or changes a figure. And each one of the different types of transformations is going to move or change the figure in a slightly different way. Like most other things in geometry, we're going to have a language of transformation. So it's important to discuss the terms that we're going to be using. The first term is going to be pre-image. A pre-image is simply the figure before it's been transformed. And that would lend itself nicely to the next term, which is image. And an image is the figure after it's been transformed. Now, again, I mentioned earlier that the primary transformations are translation, reflection, rotation, and dilation. Now, one of the other primary terms we need to understand is the concept of a rigid motion. And a rigid motion is a transformation of group of transformations that preserves angle measure and length. This means that the shape and size of the original figure is preserved. Now, the three transformations that are rigid motions are going to be translation, reflection, and rotation. So we're going to cover those first. So let's talk about translation. In a translation, we're simply moving all the points of a figure the same direction and the same distance. So here we have a pre-image, that is the image before it's been transformed, and here we have the image. And you can see that moving from here to here, we've moved 6 units to the right, and we've moved 3 units up. So this point has been moved 6 units and 3, 6 and 3, 6, 1, 2, 3. So all the points of the pre-image are moved 6 and 3. If that's all we had was that terminology, moving 6 to the right and 3 up, or 6 to the left and 4 down, that would be rather tedious to define a transformation for an entire object. It's not too bad with 3 points, but if the figure had more than 3 points, it would start to get rather tedious. Fortunately, we have other mechanisms. The first of those mechanisms is called a vector. A vector is a quantity that specifies both direction and magnitude, that is, size, length, or distance. Now, the way we identify vectors is it looks a little bit like a ray. It has an endpoint and an arrow at the other end as you graph it, but it indicates that it goes from point A to point B. Now, this happens to be vector U, and this would be the symbolism. A U with, looks like a hook with one barb on it. And you could also name this vector AB, going from A to B. That indicates direction from A to B, similar to a ray. And again, that barb with that little hook with one barb on it. So a vector has several pieces to it. This point, the starting point, is called the initial point. And it's just as it sounds, it's the starting point of the vector. This would be the terminal point, and that's the final endpoint of the vector. The magnitude would be the length of that piece, the length of that segment from here to here. Now, one of the ways to specify vectors is to use what's known as the component form. And in component form, we break the vector into two components, the horizontal and vertical component. And you can see that this horizontal component is 4 units long, 1, 2, 3, 4, and the vertical component is 1, 2, 3, 4, 5. So the component form of the vector is given by the horizontal component first, followed by the vertical component. And it's enclosed in less than, greater than symbols here. So this would be the component form of vector AB. And it simply means start from point A, move 4 units, positive 4 units, that means 4 units to the right, and 5 units up. That's what the component form is saying. If this were negative 4, 5, we would go 4 units to the left and 5 units up. If this were negative 4, negative 5, we would go 4 to the left and 5 down, and so on. So we have several ways now to indicate this. We can indicate it graphically. We can indicate it with the component form here. There's also a second mechanism that we can use to specify a transformation, in this case a translation, and that's using transformational notation. Now the transformation notation has a specific format, so let's take a look at that. Now what this is saying is that the coordinates for x, y go to some constant times x plus or minus some constant times y plus or minus some other constant. In this case, what we would have is we're moving 4 units to the right and 5 units up. So that transformation notation for this specific transformation would look like the following. We would have x, y goes to x plus 4, y plus 5. Because we're going 4 units to the right and 5 units up. Now don't let this A and C term confuse you. This is the general notation for any transformation. That could be dilation, it could be translation, reflection, rotation, any of those. The only ones we're using here are the B and D in this case. So a translation, up 5 and to the right 4 would be x plus 4, y plus 5. Let's take a look at an example and put this into use. In this example, we have a preimage and an image. First thing I want to do here, just for clarity's sake, is I want to go ahead and label the points of the preimage and the image. So these are going to be our primary points. So we're going to label these A, B, and C. Now, that's a bad B. The image points are going to have a slightly different denotation. This one's going to be A prime, this one will be B prime, and this one will be C prime. And this is generally the way you'll see them denoted. If we have multiple transformations, it may be a double prime or a triple prime, but this is generally how you're going to see it denoted. Now, we can see that point A has been moved over to the right, and it's been moved over 1, 2, 3, 4, 5 units to the right. And it's been moved up 1, 2, 3. So 5 to the right and 3 up. Now our transformation notation for this transformation would be x, y goes to x plus 1, 2, 3, 4, 5. 5, y plus 1, 2, 3. Now that transformation notation would be applied to every point in the preimage to get the image points. So this point being 2, 5 would go to 2 plus 5, which is 7, and 5 plus 3, which is 8, and 7, 8. This point having coordinates 8 and 1. 8 plus 5 is 13, and 1 plus 3 is 4. And there we have it. That's how you would apply a transformation notation to each point in the preimage to get your image. Now the same transformation could also be denoted using a vector. To go from A to A prime, it would go something like this. Something like this, starting here and going up here. So there's our vector. and the vector would go 4 or 5, 3. So to write our vector then, we have 5, 3. So that would be the vector notation for this transformation. The horizontal component is 5, the vertical component is 3. We're moving horizontally 5 and vertically 3. So that's the basics of how to do a translation using transformation notation and vector notation. Let's take a look at another example. In this example, we're given the coordinates of a triangle ABC, which are 1, 2, 4, 4, and 3, 5, and we want to use this vector to translate it. So let's first go ahead and plot our triangle. So we have 1, 2, so that point's there, and 4, 4, that point is there, and 3, 5, that point is there. Now, let's go ahead and draw our triangle real quick. Here's the triangle, and we need to use this vector to translate it. So let's go ahead and rewrite the points and do our calculation here. We have point 1, 2, 4, 4, and 3, 5. We're going to go 2 units in the positive x direction, so this 1 goes to 3. 1 plus 2 is 3, and 2 minus 1 is 1. And so if this is A, this is A prime. If this is B, B prime. 4 plus 2 is 6. 4 minus 1 is 3. And if this is C, this would be C prime. 3 plus 2 is 5. 5 minus 1 is 4. These are our new points. So we're going to put those in a different color. And we have point 3, 1, 3, 1, and 6, 3, and 5, 4. And there we have it. The primary triangle, the white one, is translated to the yellow triangle. We went 2 units to the right, 1 unit down. All right, let's try another example. In this example, we're taking the same pre-image, the same triangle ABC, and we're applying this transformation notation to it. So we're going left 2 and up 3. And we're using this white one to our new one. So let's go ahead and put our new points. We'll call our new one a double prime. And we're taking this and subtracting 2 from it. So 1 minus 2 is negative 1. And 2 plus 3, 5. B double prime is 4 minus 2 is 2. And 4 plus 3, 7. C double prime is 3 minus 2, 1. And 5 plus 3, 8. So let's go ahead and plot those now. I've gone ahead and plotted these points, negative 1, 5, negative 1, 5, 2, 7, 2, 7, 1, 8, 1, 8. That takes this one, it goes to the left 2, 1, 2, and up 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. That's translation. In the next part, we're going to go ahead with a new term called composition. And so I will talk to you in the next part.